Hello, everyone. I'm Surya Gulagani, Director Marketing here at DataGaps, and thank you for joining us today. Before we get started, we have a couple of quick housekeeping comments. First, we have muted all mics so that there are no unintended distractions. Next, the chat room is open so you can interact with us through the chat. And finally, at the end of the session, we'll open it up for Q&A. Thanks again for joining us today. In our last couple of webinars, we introduced our DataOps suite, its modules, its functionality, and how we can automate end-to-end data migration testing using this DataOps suite. Today, in this webinar, we'll be discussing one of the modules inside DataOps suite, TDM, that is Test Data Manager. So let me make a few introductions today. On the panel, we have David Small, VP Sales and Marketing here at DataGaps, and Shubhanshu Dikshit, Product Manager at DataGaps. And here is our agenda for today. We'll have a quick overview of what DataOps suite is and its modules. Then we move into DataOps suite TDM overview. Then we'll demonstrate some use cases that were important to our customers and followed by a Q&A session. Now I'll hand it over to Dave.
Thanks, Ilya, and thank you everyone for attending today. Look forward to having a good session. So again, my name's Dave Small. I'm Vice President of Sales and Marketing at DataGaps, and just wanted to go through a quick commercial on DataGaps and what we do on a day-to-day basis. We focus on that end-to-end validation of the data journey through the enterprise. So as it comes into the enterprise, it's being ingested into the enterprise. We do data quality checks at that point. We also do things such as ETL validation, a number of things as the data is moved through the enterprise, and then as it gets consumed in the BI platform of choice, we do validations there as well. So the end game or the end goal is really to allow organizations to make decisions based upon trusted data. That's our mission. We do have DataOps suite. We've gone through the ETL Validator in a prior session. So if you're interested in what we do on data quality and ETL validation, we have that done in a prior session. It's out on YouTube. We also provide data quality monitoring, and that's the ability to look at the data that's in your enterprise and score that data, and then roll that score up to a table level, up to a model level or the data warehouse. And as scores begin to change, if they're beginning to diminish, you can quickly track where that's happening. So that's what data quality monitoring is about. And then the companion product, BI Validator, does the validation against your Tableau or Power BI or Oracle BI implementation. So that's a companion product to the products and DataOps suite. Today we'll be talking about Test Data Manager. And what Test Data Manager does is it provides you with the ability to take samples of production data. We read those it's the sample of the production data, and we actually create synthetic test data based upon the samples that we read. So we hide, or not hide, but we actually replace personal identification information. We keep correlations of foreign key and primary key and other correlations in the production data. Once we run that through the test data management capability and we generate data sets that then can be loaded into flat files or to databases if that's what you're looking to be able to do. So what are the use cases for test data management? Well, a lot of people, probably one of the biggest use cases is application testing. So you don't necessarily want your testers to be exposed to personal identification information for data privacy reasons. So you create the synthetic test data so they can test the applications that they're creating. We also see people using it for ETL stress testing to see how much stress or how many records you can move through the ETL process and understand and still meet your SLAs. It also is used a lot for data quality testing. So testing of your data quality rules can be tested by generating the test data through TDM. And then finally, as you begin to look at your BI platform, you can use the test data that's generated to stress the BI platform based upon volumes of data, and also check for regression. So those are some of the typical use cases for the output from test data management. One final comment from me before I turn this over to Shubhanshu is that the way that we do and create the test data is we take the sample of your production data, we identify personal identification information automatically, and then we provide over 90 plus fake data sources which would be used to generate the fake data to replace the personal identification information and other types of things. So addresses, cities, email addresses, country, continent, all those kinds of things. There's over 90 different data sources that we bring to bear in order to help you with generating your test data. So with that, let me turn this over to Shubhanshu. If you can share your screen, and he will go through the demonstration of test data management.
Sure. All right. Surya, can you help me? Can you see my screen?
Yes.
Yes, we can see it.
Okay, thank you. Thanks a lot, David, for that very informative intro. So what we're going to do right now is that we're going to go through a short demo on how exactly Test Data Manager is being configured, what is the use cases that we go through, what are the prerequisites, and most importantly, how exactly you can place this data back into your local machine or back to your DB. So to get started, before we get to the TDM, which is, as you can see right here, we first need to define our sources. As David said earlier, we need a sample data set in most cases to actually create the corresponding test data. This is created in sources. We'll quickly skim through this and data model before we get to Test Data Manager. As you see, DataOps Suite actually supports a variety of data sources, including your common JDBC connectors, as well as local S3, and every format, including CSV, Parquet, and other aspects as well. We have support for most files and data sources. These sources are used for connecting to the corresponding database or location, and then we create a corresponding data model for these set of sources. A data model is just a connection given a set of schemas and a set of tables so that our system understands these are the set of tables that fall under this particular data model. And so with this segregation, the system works more efficiently, and the user can also work with specific models instead of working at the entire data source as a whole. Now that we've defined a data model, we can get into Test Data Manager. In the extra options, we have Test Data Manager right here. What you see in front of you are two options, data models and data sets. On the right, you see the list of data models that are available and already pre-configured. First, we'll get into data models. These models are the same as the ones that we showcased earlier, and we will be looking at the citizens dataset, which I have already prepared for this particular webinar. Before we look at the exact table, let me put your attention to the plus icon and the import icon. So these two icons are to add particular tables. An import table will help you choose a particular table for sampling from your existing data sources. You can choose any of the data sources that you've defined earlier, choose a corresponding schema in there, search for the exact table that you want to. There's also a refresh system in case your source keeps refreshing every now and then. Search for a particular table, which can be this one. Add it, add multiple if you would want to. And then correspondingly, make them part of your system. As we can see, we have added customer test data as well as customer employee. These ones can be easily deleted from our system and edited as well. All right. Now, once a table has been added using a DB, we can also add a table on our own. So as David mentioned, usually a sample data set is needed. But in case you do not have a sample data set, but have a data dictionary where you know exactly what columns correspond to what data types, what is the range of these things, you can create your very own data set from scratch. And we will be using mostly fake data, which is a subsection in our synthetic data, which we'll cover on later. But that is one of the primary use cases. We have given this option that even if you don't have sample data, but you have a data dictionary, you can still create a great amount of data set using the data dictionary. So once you have created your corresponding data set, the first thing that you will see are columns. Now, columns are very self-explanatory. This is your entire table explanation. This is your metadata. You have your corresponding keys, aliases, data type, whether this entity is null, whether it has a corresponding mapping in CDM, its order, and other such details. The first button that you see is auto detect entities. This is a tool that we have offered that helps detect PII and ensures that in the subsequent test data set, this particular column will not be copied as such. This is to ensure that your production level data set is being sampled, but the PII data is being rejected of sorts. Another data set will replace it, but will ensure that its uniqueness and the list of values is preserved. More on that later. If you do not have certain columns in your test data, or your sample data is lacking a few columns, you can manually add a bunch of columns as shown here. The name, the alias, the corresponding data type, as well as the length of the data type. A very simple example, it could be that an n character or a particular n car data type can have a length of 10. This implies that this particular column can only have a character length of 10. Also, whether this entity can be null is also chosen here. A very simple request from most of our teams, engineering team, is to definitely reuse auto detect entities as much as possible, because it does not just go into PII, but it also gets the metadata from the source directly, and it really shortens the amount of work you have to do yourself. We'll skip relations for now as it gets into foreign keys. We have a specific example for that, and we'll get into sample data. Let's get to a very specific system. Yes. Sample data is this is the set of data sets that the product is going to use to sample using the IML algorithm to later on create synthetic data. Data set is nothing but a system, or this is just a snippet of the data set that we have present here, which can be downloaded, and a subsequent sample can also be put in. Obviously, we can choose if we want to sample only 100 records or 2000 records or anything like that. The main reason this is given as a condition is because percentages and key relations and list of values, distinct list of values, are consistent throughout synthetic data. What that means is that if your sample data has about 5 distinct list of values, basically there are 5 distinct values that you see in a particular column, and you've defined in the synthetic data that yes, I want only 5 these 5 distinct values. A business example to accompany this is that say that your particular data set should only have data from 5 cities. Even if you expand your records to from 100 to 20,000, the number of cities should not change. It should have those same 5 cities. So our system analyzes that, understands that okay, only these 5 cities are to be present, and it picks that from the samples. So this is why we have defined the number of samples, the where condition as well, in case you want to create sample data based on very specific subset. A where clause is also provided, and also a limit to ensure that not too many systems are being pulled into our product, to ensure that things are efficient and there is no lag here. Now, once we have defined the sample data, we can now get into synthetic data. Once again, the recommendation from the product team and from us is to use the auto recommend. Auto recommend looks at the data type, looks at the sample data, and figures out on its own what is the best generator type for this particular entity. Now, we'll go from very simple ones, which is a customer key. Customer key here was an integer data type, and correspondingly, we have defined that this particular generator can also be integer data type. Now, the user is given complete control as to exactly which type or subtype can be given here. We have a lot of options in each subsequent values where we can define that a customer key can be greater than 56, or be negative, or between, or other such options. We are going to spend a good amount of time in type, but before that, I just want to reiterate that this particular auto recommend takes into account the sample data as well as the data type and schema defined by the user to create the best suited generator type. So now let's get into the details on what the different types do we see right now. So We have a lot of them, and I would first start with the categorical one. Categorical one, let me just discard this changes. The categorical one is the one that actually takes into account the sample data. Here you see constraints defined as none. A none constraint here implies that the sample data is being picked up as is without any constraints. Implies if you have Mr., Mrs., Senior, or other stuff in your title, those values are being taken. Those values, percentages are being taken. The statistics, the way those values are distributed is taken, and those are being put into. If we add some constraints, only constraints can be added with numerical or categorical domain. This is further categorization to ensure more control on your test data. If you add certain groups, these act as aggregates. Say you want Mr. and Senior together. You can define those here, and then the test data will ensure that Mr. and Senior get the same type. All of these are just to ensure that you have more control over your test data, which also goes in hand with black box testing, which we'll get into later. Now, going back to other things, we have composite key. Key here is pretty straightforward. A key can be a string, integer, or a foreign key. A foreign key will have to be defined in relations. We'll come to that later. But another composite key is just a key system that we can define. This is your primary keys or any other key table that you see in your system. Next, we have date time. It's pretty self-explanatory, where you can define date or time or both and give a specific format for each of them. After that, we have foreign a key. Actually, we'll go to formula. Before that, we'll skip these two. They are pretty large, and we'll come to those later. Then we have formula, and this is, as you can see, a Python code system. In case you have something very specific that you want to get into, that your test data should follow specific rules, you can input a complete formula to actually get this thing resolved. We also have our help option to give you some sample coding that help you with the system. Next, we have null, which is pretty self-explanatory, that you do not want any kind of filling in the system. Then we have numerical, where you can define whether something is integer, float, and as we saw earlier, you can put some constraints on top of it. Then we have primary key. Here we can choose a particular system and make sure that the key here becomes unique. We also have an added option of giving a GUID here. This will ensure that there is a 32-bit or a 16-bit GUID present in your data type. And reference data. So before we get into reference data, I would like to quickly go back and get into fake data. So in fake data, you must have, if you guys remember, there was a screen that David showed. This is that screen. Now, this is a list of 90 plus fake data sets that the product provides. This can primarily come in use when you're trying to create fake data from scratch, because we have a lot of groups and a lot of categories in our system. Everything from color to addresses to IP addresses to dates to years to anything with to IMEI codes to finance related systems, from companies to ISO codes to stock exchanges to stock names, currencies, IP addresses, like I said earlier, random integers, random floors, random strings, email addresses, blood groups, full names, academic degrees. As you can see, 90 plus is a big thing, and 90 plus here implies distinct groups, not just the entire list of data sets. So in most cases, what we have understood from our clients is that if you want to create fake data, this entire fake data provider can help you without any sample data being used. So again, of course, adding this is as simple as clicking on it and just going, yes, this is what I want to add. If I want to search for something specific, like say address, I can add it from here itself. And expected output is showcasing what kind of system we are to expect from this. And going, very related to that is reference data. Now, one thing I want to point out with regards to fake data, in our future releases, we are going to ensure that you can add your own fake data sets in the system as well. What that means is that here, if I want to add a very particular set of cities, we can add that as well. But in some cases, take for example, in pharma industries, you have something called payers. These are these are certain lists that are very specific to only your industry or maybe even your use case, where fake data might not be used even after the update that we provide. In that case, we have something called reference data. Here, I have created something called address type. Now, address type here is a list of values that I have defined myself using a CSV file. These are just four values called home, work, and other things. Basically home, work, postal, and so on. These are address types. But more importantly, this is a list that I have defined and given to the tool. Now, when I want to ensure that a particular column contains only 6 list of values, irrespective of my sample data, I can use this particular reference data to ensure that the columns in the fake data have only these values, these approved values. That is what reference data is. Now, finally, you can try to just preview. A preview system works just to showcase how the fake data looks. It'll take a little time since we have given our sample data as around 500, I think 5,000 records. But this particular window is going to showcase exactly how our system looks, because it's actually going to generate these data sets in real time. There we go. As we can see, we have this test. This is all fake data created by the sample of our original customer data. Of course, we can expand to look at this data set in more details, given that this is a sample, and we can download this particular system as well. Right. Now, before we move on to other things, we'd like to go back to relations. And for this, I would like to use another table called fact sales quota. All these tables, by the way, are from the Microsoft developed tables, in case you're wondering. Okay. Here we have our main employee key as our primary key. This is our foreign key, basically. What we want to define here is that we have our employee table where we have certain employee keys. And what I want to ensure is that whatever fake data is being generated in my fact sales quota has primary keys, has employee keys which are valid, which are nothing but the employee keys present in our system. Therefore, firstly, I define the relation. Of course, if you are importing tables, there's a very good chance that the system will automatically identify that, yes, this particular relation has been defined already in our schema. So this, you won't even have to do it. In case you want to manually do it, you can obviously add relations and define what's the child column, what's the parent column, and what's the parent table. Of course, also if it's one-to-one or one-to-many. Here we have defined things as one-to-one already, and of course can be edited as well. And then in synthetic data, we define this particular generator type as foreign key. What this is going to ensure is that the data generated in employee key column is valid data in accordance to the dim employee. Therefore, if you want to test some new data sets that are going to come and you know the relations of these, you can do that as well. And you can create them in a bulk so that you can test your data set properly and efficiently. This is what foreign key and what relations is about. All right. So with that, we basically conclude what data models is. Now let's get into, once we can create the system, once we have defined how exactly do we generate and we load them into our systems. For that, we're going to go to data sets. So in our data sets, we first define in which model this particular data set is going to go through. And most importantly, we define what is the target going to be. This target can be any target defined in your sources, the first window that we saw. This can be any local S3, AWS S3, or a DB as well. Here I've just given a folder name as Femi into S3, but I can also define this as a corresponding data source, DB, with a default schema. Once that is done, we can choose the tables we want to correspondingly generate results for, how many rows we want to generate results for. And once we go there, we can create a corresponding load. So once these rows are defined, they are generated, it's upon the user to save them, either append them to our corresponding schema, either to drop the table or to truncate them, basically replace the entire data set with new test data. Note that in generate, you can choose n number of tables as well. So if you have imported your entire data set, you can choose the entire system here and then correspondingly load into your testing data set or your dev environment to test your pipeline. And this is how, and once we click generate, we will have successfully generated these particular tables into our system. Now, with that, we conclude the entire test data manager. But before I leave, I just want to address a few questions on how exactly this is being used by our clients. The first question is regards to black box testing. How exactly does this particular TDM gets used for testing, testing our ETLs or testing our systems? This particular product is being used to black box test is by ensuring the so black box. The main principle behind black box testing is that it works by making sure your variables are out of bounds in some cases, so as to test your where conditions and your functions, so to speak. And that can be done right here. You can choose your data types to exceed certain limits, or you can choose certain entities to be null. Therefore, you ensure that these particular data sets are by choice getting out of your system. And therefore, you can see whether your particular ETL pipeline fails or passes or does not cause an error if it catches issues in the system. Depending on your use case, it could be that you would want your ETL's pipeline to fail on purpose, even if there's one small issue in the data type. That could be a use case. Or you want to ensure that your ETL system power throughs even if there is data type changes or character limits being broken through. That's how you do black box testing in our system. The next thing is with regards to ETL performance testing. As I said earlier, you can import your entire data set here and correspondingly create fake data for your entire dev environment. What a few of our clients do is that they use this to stress test their entire pipeline. Instead of working with just 20,000, which is a usual count that one of our clients sees, they will use it to create 1 lakh or even 5 lakh records on most of their tables. This is to see exactly which the limits of their pipeline. Because you can never replicate how the production throughput now, can you? So what we do beforehand itself, we test the data set, we test the pipeline by pushing through as many records as we can while maintaining that, the records are in most cases valid. This is a set of records that sample from the original record. And so thus ETL performance testing is being performed. Then our next question is with regards to the format of the generated data, quickly going back to our data sets. As I said, if I choose to select S3 here or a local system, I can choose if you JSON, CSV, or any other Spark as well. As you can see, XML is also present right here. Format is again on us, so you can even download this data set to use it correspondingly in your other tools. And speaking of other tools, one of the other modules that DataOps suite provides is the BI Validator. And one of the use cases that we have is that test data is generated and then pushed across, and correspondingly our BI Validator tool can actually look out for the efficiency of your BI system. It checks whether your storage and whether your cores are actually running as efficiently as possible within your BI system, basically seeing whether or not your BI system can handle higher loads in subsequent times or not. So that is basically our add-in with BI Validator, on which we're going to have other webinars as well in the future. So with that, I would like to conclude this particular demo and give the control back to David and Surya.
Thank you, Subhanshu. Now that comes to the end of today's webinar, and we have a couple of webinars scheduled that give a more interactive understanding about what DataOps suite is. Basically, the next webinar is coming up is about BI Validator. We will understand what BI Validator does and how it complements along with the DataOps suite. And I've shared some useful links if in case anybody is interested in looking at the tool or want to have a trial version of the tool. Just popped up those links into the chat window so that you can have a look at it. Okay. Dave, any comments you want to add?
Yes, just a couple. The benefits, is that you can do 100% generation of your test data. And what that does is it really reduces the cost. In order to create test data, it takes typically a lot of time and effort to do it correctly. And some people go about that in a manual fashion, which is very costly, which means it's not repeatable. It also means that your time to market, the time that you can get your ETL process in place, or the time that you can test your applications, those are greatly diminished if you're using something like Test Data Manager. If you're doing that in a manual basis, then the timeline is elongated. So those are some of the benefits. And with that, So do we have any questions in the chat?
Yes. We have one from Ankit. Hey, I'm just reading out the question. Hey, for TDM service, only synthetic data generator is there. Do you serve data masking, subsetting, visualization also?
I would like to take that answer. Yes. Virtualization. Thanks for the comment. Firstly, data masking is present as discussed with the PII, the personal identifier information. We have gone with the nomenclature of PII because we found that a few of our clients use PII explicitly. But what I assume from your question with regards to data masking is that any sort of personal data or data set that or data types that you do not want to put into your dev environment, which could be IDs, which could be certain keys as well, can be defined as data mask. And yes, you in your when you define your columns, you can very well define that this particular column needs to be masked. You have given it the name of PII columns, personal identifier columns, but data masking works for that. As for subsetting, I'm not entirely sure of this particular nomenclature and what exactly you mean by that, but you can feel free to connect with us separately also on that. We are more than happy to connect with you offline on these particular questions as well. The same goes for virtualization as well. I'm not entirely sure what the exact question is with regards to test data manager for virtualization. David, in case you have something, you can definitely help me out here.
No, I think if we get a little bit of clarification, happy to respond outside of this session. That's fine. So yeah, any other questions in the chat?
Nothing more. As said, probably I think we have the details and we'll reach back to one who is just asking us, Ankit Maheshwari, right? Yeah, we can reach back.
Okay. Well, thank you everyone for attending the session today. Hopefully it was helpful for you to understand our approach to test data management. There's a lot of capability in the product, and having the test data management piece in the DataOps suite serves a number of purposes. One is, to do the ETL testing and stress testing, and also as data moves into your BI platform, you can use the test data management to create test data for that as well. So we appreciate your time today and give you back a little bit of time. So thank you very much.
Thank you, Dave. Thank you, everyone, for coming to this session today. Thanks again.
Thank you.